Okay, let's change some things. We need to modify things because, in case you hadn't realized, we have very little left in the notes. So I gave you a homework assignment the other day. We're going to reduce it.
I like your little picture.
Thank you.
Reduce, reuse, recycle.
We are going to reduce. So on the homework that I passed out, that's supposed to be for Chapter 5.
Is it section 1?
The whole page that said Chapter 5 homework. For all the Chapter 5 homework. So on the handout, can I borrow your phone? And we're actually going to reduce it as follows. So there are lots of sections. There are, let's see, 1, 2, 3, 4, 5, 6 different sections. You have to work 3 per section. So, and there are 6 sections. So that means there has to be 18 problems.
We went from the last one where there's like 50-something problems to this one where there's 18.
Yeah, because to me this one's way. In my personal opinion, this is way easier. Now, you would get bonus if you did more yes, of course you would. If you don't understand a topic, for instance, today we're going over mutually exclusive and independent. So if you're confused about a topic, would it be wise to work more from that section? Yes. But otherwise, we're going to reduce it drastically because of the following. You didn't realize we're finishing up today. So I am not going to get to see you tomorrow. So come Monday, we're going to do our Frappy. And then come Tuesday, we're going to have our Chapter 5 test. Which is good because we need to get to Chapter 6 as quickly as possible. So since our test is coming up so quickly, that's why we're reducing. We're only going to do 1 Frappy, so we'll also talk about some multiple choice then as well. Even though it's quick and even though we haven't spent that long on it, it's a easy to comprehend section and it ends up making up a good portion of the exam. In fact, I think it's over 12%. I think it's like 12.5% of the overall exam is probability. Fairly enough. So, okay, is everyone good with the reduction? Yes, dear.
With the Frappy, what, like, would you say it's easier or harder than the past ones you've done?
I would say it's easier. I would definitely say it's easier. But again, I like probability, so if this does not mean you've not really liked what we've been doing lately, then you're not going to do that. Okay, I'll leave that on the screen for a second. We're finishing the notes, and I finished the notes. It shouldn't take long. If you want to work on that homework, that's fine. Or if you want to look through the multiple choice questions so your group can get all the points coming in, that's fine too. I don't care as long as you do some sort of math. Okay. We have to finish the notes first. Okay, so just 3 per section. And there are 6 sections. Yeah, the Frappy's Monday, and then we'll do tests Tuesday. Which is dangerous because you've got this long 3-day weekend to forget all the probability we've been discussing, but it is what it is. You gotta get through Chapter 6.
Wait, what am I going to be in for Tuesday?
Tuesday? For band?
Yeah.
Why?
Wait, ensemble. We've got.
We got a dude coming.
Oh, okay.
All day.
Can you do Wednesday morning 0 period then?
Maybe? No.
You could always do Tuesday morning 0 period.
Yeah, you just need to find a 0 period.
Crap, what is suicide? Can you give us more time for these things?
I don't know.
Is that all 4? So there's 5 of you? Samantha. So it's you, Louise, Hunter, Shalia, and Sally?
This table and
Like,
Sally.
it's actually half the class.
So bring me my finger. That annoys me so, but I can do the following. I can make the following concession. I'll say that we will do the test on Tuesday and Wednesday. We'll do the multiple choice part without you, and we'll do the free response with you, so you'll just need to find a time in your life to come make up the multiple choice. That's what we'll do. So we'll probably review at the beginning of class, so they'll have a little more advantage than you, because they'll get more of every year, and we'll leave the multiple choice. Yes, I will. course I
Other
know.
news, Chris Hemsworth is
Okay, thank you for telling me that. Okay, let's go. You who likes to talk, will you read the mini women?
What?
The next example that says mini women.
Very backstage.
I don't know, below what we did yesterday.
The very last.
Exercise.
Yes.
Many women choose to have annual
Mammograms.
mammograms to screen for breast cancer after age 40. A mammogram isn't foolproof. Sometimes the test suggests that a woman has breast cancer when she really doesn't, a false positive result. Other times the test says that a woman doesn't have breast cancer when she actually does, a false negative.
Okay, I want to pause right there. I've seen this question or variations of it so often, so I would probably put a star by it. For some reason, this is their jam. They like asking the ones about the false positives and the false negatives. I don't know why. I find them annoying like you will, but it is what it is. So,
I thought you were saying mammograms.
Yeah.
Yeah, me
No.
too.
I thought it's been better to
no, I meant they find, they'll tell you about some, for instance, there's one in your textbook about a hearing test for babies, and there's a probability that it'll say they have hearing loss and they don't, and probability that it says they have no hearing loss and they do. Anyway, it's terrible. Oh well. Moving on, it's just a good kind of question, I guess, they think. I don't know, I find it annoying. Okay, go ahead and continue reading.
Supposedly we know the following information about breast cancer mammograms in the region. 1% of women aged 40 or over in the region have breast cancer. For women who have breast cancer, the probability of a negative mammogram is 0.03. Women who do have breast cancer, the probability of a positive mammogram is 6%.
Okay, and then part A wants us to draw 3 diagrams. So let's start there.
What's it? I saw a big tree. I was like, tree in
The
it.
body diagram.
So you've had some sort of a test.
I love tree diagrams.
It looked like trees.
Yeah. So you've had some sort of a test, and you have a positive. You test positive, or you take the test and you test negative.
Makes sense.
It would make sense, except they didn't tell us the percentage of overall people who make positive and negative, did they? So was this an accurate drawing for the 3 things given?
For women who have breast cancer, the probability of negative mammogram is 0.0. That's a false positive.
Yeah. So we have the positive, negative, and I guess we have to address
Yeah, false or true.
if it's true, or if that's actually a false.
True or dare.
And then if this is a true, or if this is a false. That's true. So again, that first statement, 1% of women aged over 40 in this region have breast cancer. So they actually have it. So we don't know if they tested positive or negative. We assume they tested positive. And then the second one says for women who do have breast cancer, so for sure they had it, the probability of a negative mammogram, so they had a negative false, is 6%. So I know that this is supposed to be a 6. So I know we use that last statement. They don't have breast cancer. Did I do that wrong? They don't have breast cancer. The probability of a positive mammogram. She should have been negative.
So it's true. Wait. Positive mammogram.
Okay, I read that wrong. So I have to relate this all back. I don't have it in the moment. So let's go back. So this third statement saying did she test positive or negative?
So she tested positive, or she tested negative, but she does have it. So it's a false negative.
That's what I thought, but I have
That
questioning
makes
my own
sense, right?
sanity.
Because the probability is positive.
Don't
mammogram,
have breast
you have it.
cancer, so you don't have it, so for sure it's a false.
Yeah.
And then the probability of a positive mammogram is 6%. So she did test negative. So
I think, wouldn't it be she
94?
positive?
No, it's for a woman who doesn't have breast cancer.
Yeah, but
the
it's saying-
probability of the test reading positive is 6%.
Yeah, so wouldn't it be... So
It would
it's
be-
a negative false.
It would be,
So it is a negative false because she doesn't have it,
but it's saying she does, right? For
Could
the
be
positive
positive.
mammogram.
And then it makes you question, like, couldn't we make this tree less confusing? Like, maybe I can make my life a little less stressed. So what if we get to be the ones who make the
I think
tree.
if you put under a positive,
It'd be a
positive
false
fault,
positive.
6%.
Be a false positive.
6%.
Okay, we'll come back to that. I'm having another thought since then. So maybe I shouldn't even use the words positive and negative, because maybe that's what's tripping me up.
You're right. I think
So maybe I should say test, cancer, no cancer.
Yeah, you're
Yes and no.
You're right.
Test results true. Test results
I love how the way we simplified it, but making it more complex.
lie. And then I'm going to say true,
And false.
lie. And I'm not going to say true or false because the false positive thing is where my brain gets a little
So
shook.
that makes sense. So this says she has cancer, but she doesn't actually feel false love. Yeah,
Okay, so she doesn't have breast cancer. She's a no cancer. But she had a lie that said she really did have it, so it was a lie. So this is why it's the 6 down here. Okay. Woo! And literally all we've done is read through the third statement and put a number with it.
So Mark the first time.
Because I'm thinking in my brain, the false positive, the false negative, that connotation is confusing me, so I'm confusing myself. I'm the one designing this tree diagram. Since I'm the one who's confused, why not redesign the diagram? So instead of it saying false or positive, instead it says cancer, no cancer. It says specifically she has no cancer, so I know she's on the no cancer limb. And then the test lied and said she had cancer, so that's why I know it goes here. If you liked this, you can keep going with this, but I mean, my blind brain at 7th period is totally here. Okay, so the one before that says women who have breast cancer, so she has cancer. The probability of a negative mammogram is 0.03. So she has it, but her test results were negative, so her test results were a lie. Because she had it, so her test results should have been positive. So that's why we're going to put the 0.03 there. And then, last but not least, that very top statement said, 1% of women aged 40 or over in this region have breast cancer. So literally, test, but I have cancer. So we're going to put that with the 1%.
Wait, but that could be a false. So then you wouldn't put it there. So you would
Put
have
it
to
next to
subtract
the
the other
one
one.
at top.
So like the no cancer lie and the no cancer true have to add up to equal
Yeah.
0.01. Or 0.1. No, 0.01.
So the no cancer lie, because if it's a no cancer and a lie, then she literally has cancer. Or if it's cancer true, we just found out with that top statement they're supposed to add up to 0.01, which seems confusing because no cancer lie was 0.06, but we're forgetting something.
Are we?
I don't like this one.
I'm telling you, I never like these. No, you have. Sadly, these continue to come up over and over again.
That's great.
Wait, so it says she. Wait, okay.
What we're not thinking through is that to get to the end of the branch, we normally multiply this number times this number to get the final number, and this number times this number to get the final number. So if we knew the percent of people who actually have cancer and the percent of people who actually have no cancer, we can multiply it out and figure out what's going on. Terrible. Terrible. Terrible, terrible.
I don't like this.
So we drew a tree diagram, but they didn't tell us, like, I mean, do we redesign our...
I mean, I just think like, because the test doesn't tell you whether or not you have cancer or not. It tells you whether it thinks it does. I think that's also kind of going wrong a little bit. Because it says positive, negative, but it doesn't say whether or not you have cancer.
Okay, so basically, if I took his suggestion and applied it to, like, layman's terms, I would say, maybe we didn't make a good tree diagram the second time either.
I think like the first one's probably a little better.
Maybe we should do test and then say results true, results false. Maybe we should make a third one. Maybe our 2 tree diagrams stink. I don't know how y'all do homework at home, but like you're supposed to just go through a thought process. If I tried this, it didn't make sense. I tried something else. So results true, results false. And then we'll be more specific. Results true, cancer. Results true, no cancer. Results true, cancer. Yeah, so I'm just literally swapping up my branches, thinking maybe if I change the branch order, because they do tell us, we're supposed to decide all this ourselves, what order the branches go in.
Well, I ain't got time with AP exam to make 8 different trees. What is this?
Well, I mean, you have like 13 minutes per fruit response, so
Sure.
you do have enough time.
But there's like 4 questions.
Well,
This is only the first part.
yeah, but I mean, this if we don't figure out this part, what are we going to do for the others?
Yeah, exactly.
Miss Compton.
Yes, dear.
Would it also work to say that there's the test, and then has cancer and does not have cancer, and then the last string, or like the last 4 would be the way they got there. So if you have cancer, either
The false
a true
positive,
positive or a
false positive, true negative, false
Yeah.
negative.
Just gonna say
That,
no, right?
I mean, yeah, that would work out as well. I feel like I'm just having trouble seeing the whole thing. I thought maybe if I made a new tree diagram, suddenly this problem would be clearer to me. Yes, dear. So back to the 3 statements. She doesn't have her results were a positive mammogram, but she had no cancer. So her results were false because she had no cancer. So it's still 0.06, and then you're like, well, Ms. Compton, I'm putting the same numbers in the same places, and I agree. She has cancer, and she had a negative mammogram. Well, that would put it down here.
We should talk about the stats today. Trees, cancers, and breasts.
Absolutely. It says 1% in this region has breast cancer. And maybe this one's better
I'm sure that's a good idea.
because it says results true cancer, results false cancer. And maybe this one is better.
Miss Compton.
Yes, dear.
I was following the first diagram we did, and I got those like last 2 points.
Yeah.
But how on earth could you do the first one? If they
Again,
had-
back to, I feel like they were supposed to tell us more. Like if they told us overall percentages, we could multiply out the branches like we did yesterday. So I want to like make up my own stuff and say 30% have cancer, 70% don't have no cancer, and then when I actually multiplied out the branches, I could make this all make sense. I feel like I wasn't given enough data, which makes me question my own sanity.
This is last week's good question. I didn't say my sanity.
So then you're like, and I'm kind of with Louise of, okay, whatever, screw it, my tree diagram stinks. I did the best I could. I'm a little confused, but I got to get through B, C, and D because there are other parts I'm supposed to get to. So you just leave all these tree diagrams. You're like, God, I pray they understand I knew something. And give me at least a P for spending 5 minutes on this.
They'll get confused by all the diagrams.
Yeah. Please, and like, you might want to like, please have mercy on my soul somewhere on there. That's
I've
funny.
done that on tests.
I think it's humorous. I don't think they'll actually give you any
I'm
mercy,
not
but
saying
On
I'm
test,
sorry.
sometimes I'll put I tried at the
Yeah,
top.
I've done that.
Yeah,
So,
well-
I'm sorry you thought so.
so.
Sorry. I always put I
It's
tried.
not
But now we can handle B, C, D. Just because our tree is a little sketchy doesn't mean we can't handle the
If I see a
rest.
tree diagram, I'm just gonna write song lyrics instead. That's the real solution there.
Well, the tree diagrams are not supposed to be this complicated. So either I'm overthinking things, or they should have given us more numbers to use. Okay, but they said probability of a woman selected at random. She has cancer. Given her test was positive. So we're going to get some points for putting it in this notation. In the denominator, we clearly need to put the chance of her having a positive test.
We don't know.
Well, it did tell us. 1% or over in this one. No, it didn't tell us.
Yeah, it just tells you whether or not it could be false positive or false negative. Or true positive or false negative. Another one would.
But are we overthinking things? Or are we supposed to... Okay. Hear me out. Were we supposed to get more numbers to begin with? Are we this blind? Because it said, the last sentence said, for women who don't have breast cancer, the probability of a positive monogram is 6%. So doesn't that mean for the women who don't have breast cancer, the probability of a negative monogram is 94%?
Wait, are we supposed to do 2 trees for women that have cancer
what?
and don't have cancer?
Like, could we fill in the branches? Like, don't we? Aren't these supposed to add up to 1? So could we not fill in 0.94 plus 0.06 or 0.03 plus 0.97?
Would that round up to 200%?
Wait, I thought all of them together are not.
It is, but again, we would have a number over here, multiply this times this, get the final number, and those 4 final numbers, the
I
4
thought
final
those
numbers
were the
would
final
add up
numbers.
to 1. No, these are just part of our branches. If you recall what you did yesterday, I'll remind you. In between, yes, they add up to 100. Like the little minor branches do add up to 100%. But to figure out the totals, we actually did first branch times second branch to get the final number. First branch, second branch to get that final number. And we added up those 4, it did add up to 1.
How do we find the initial branches then?
That's the problem that we can't figure out, and I guess we're not supposed to know. But again, since I was told 3, maybe I am supposed to figure it out. I'm not this slow. I can do this. We were told the 97, and we were told the 3, so that got me the 97. We were told the 6, so that got me the 94. Why can't I be smart enough? They told me that at the end of the day, that the very first statement, 1% of women in this region have breast cancer. So they test was cancer was true, so it needs to be this final number.
But it also could be
No cancer lie. So something times 0.97 plus something times 0.06 is supposed to add up to 0.01. You what, dear?
How are we supposed to solve that? Is it the same number for each? No.
Well, if we know this one, like if we know that one's 40%, isn't this one the complement? So it's
If
1
you-
minus whatever the number we knew.
Sure. So I guess that makes sense.
Oh wait, is that supposed to be x plus 0.97 plus 1 minus x?
Yeah.
If that's true, then that's even, but
Yeah, so we're overthinking our. We were trying to do algebra today. We really wanted life to be easy. I'm telling you, anytime I see these false positives, false negatives, I start to cry inside, but it's okay.
I'm fine with that.
So
Me too.
they told us the 0.01. Let me try to explain this one last time for those of us who are.
Yeah, I thought I was doing well.
They're trying to tell us, they said 1% do have cancer. Well, that means they actually had positive results because they tested for cancer, yes, and their results were true. So we're wanting to multiply these two numbers. So whatever this is, times 0.97 should give us some number. So I'm putting an x here. So x times 0.97 should give us some number. But again, Louise is right. That is part of the people with cancer, and it's going to be the majority. The majority of people who have cancer tested positive for cancer. So there is that small percentage that you tested for no cancer, and it was a lie.
that's disappointing.
So I've got to do some number times 0.06, but I'm smart enough to realize, hey, that some number, well, if this one's x, this one's 1 minus x, because if this is 40%, I'm a 60%. If this is 70%, that's 30%. Like, I'm smart enough to understand those should add up to 1. So I'm actually going to do 0.97x plus 1 minus x times 0.06 and set that equal to 0.01. Now, was it supposed to be this deep? I don't know, but by golly, I'm going to figure this, all my bad words out.
Oh yeah, distribution.
I mean, that's
Wouldn't that be 0.06 minus 0.06x?
1.06 minus, so it's 0.97x plus 1.06 minus 0.06x.
0.06,
Oh, 1 times that is 0.06. Bless you.
Yeah.
I'm trying to make it so fast and I just can't.
Jesus.
0.97 minus 0.06 is 0.91. Subtract the 0.0x, and you'll get negative point.
Yeah.
No, because it's 10 minus 6, so it should be positive 4. No, it's not. It's not 10.
No, it's yes 1. So negative 0.0.
0.05. Okay, but
Wouldn't it be 0.004?
0.01 minus 0.06, isn't that
0.004.
0.01 minus 0.06? 1 minus 6 is negative 5. Yeah. 1 in 6 will be 5.
Gotcha.
Okay, but divide by 0.91 and tell me what you get, ma'am. But this is all ridiculous. Why am I all completely wrong anyway?
How do we have a negative probability?
You're not going to have a negative probability. So should I just assume it was 59 and I've done something wrong?
No, that makes sense. All the math makes sense.
Darn them and their indisputable problem. Again, so you still leave all this on your paper. At no point do you go crazy and erase it, because they're still going to give you points for, by God, she knew something. And then you're like, okay, but again, I've spent like 10 minutes now on part A. I got to do B, C, and D. So screw A, going to B, C, and D. Okay, so B said she has cancer, given she tested positive. So we need to know the probability that she tested positive to go in our denominator. So what is the probability for sure that she tested positive?
We don't know. We still don't know, because you could still have either one for the first and
Well, then can I just do it how I want to do it? Can I just live my life how I want to live my life? Because I know we got a negative number, but by God, that was really close to 6%. And that would make sense that about 6% of people have cancer, and about 94% have no cancer. So again, when I grade your stuff, and when they grade your tests, so Alex made a boo-boo in part A. He found some numbers, and he rolled with it with B, C, and D. They're going to give it to him from here on out. So until I figure out where the... Yeah.
Couldn't you do the point, the whole, like all of the numbers set up with x, like 0.94x plus 0.06x plus 1 minus x times 0.97 plus 1 minus x times 0.03 equals 1?
No, because specifically it said 1% have cancer. So if you said you're trying to do the cancer and test results lie, meaning they don't have cancer, along with the no cancer true. So you're trying to put all the people together.
Yeah, I'm trying to find the 100% so it evens out to an x so I can find the rest of it.
I like it. Bring me another Post-it. You know what? He suddenly made my side rant last longer. Okay. So let's see.
Part 2.
He said maybe we should do all the branches. Okay. So we know if we multiplied out all the branches, the way we did in our problem the other day, with Federer and his serves, that eventually all the numbers are supposed to add up to 1. Because they're supposed to add up to 100%. So with that in mind, maybe we should do x times 0.97, x times 0.03, 1 minus x times 0.94, 1 minus x times 0.06, and set that equal to 1. That was Hunter's suggestion. It's not a bad one. Don't know if it'll work. Worth a shot. I mean, it should work, but the last suggestion should have worked too, and here we are still, so you know.
Me too.
So the first one will equal x, it'll just equal x, because they'll add up equal x. And then the second one, the other one will also equal. Won't the second one just equal negative x? If you add like terms, it'll be, yeah.
Don't ruin all my dreams.
Yeah, so then you add those two, and then you have no x.
This makes me angry because you just get down to 1 equals 1.
Yeah.
Forget you, Hunter. That was the worst suggestion ever. No, Hunter. We're not doing that. We're going back to my original suggestion.
That makes sense why it would be 1 equals 1.
Well, yes, it does, and I feel really stupid for doing it. Hunter! Hunter!
Makes me angry.
Hunter! Ah!
Holy God.
Okay,
so
so
confused.
you know how this was wrong, and we know it's wrong because it's negative? But we're going to roll with it, because it makes sense that about 6% have cancer. So we're going to say 0.06 is X, and they have cancer, which means about 0.94 don't have cancer. Woo! We got some numbers. We made them up. So you get stuck on your tree diagram, because sometimes tree diagrams are a pain, I'm not going to lie. And then you're like, okay, well, I made up these two numbers, so I acknowledge I'm going to miss part of part A and only get the P. But if you roll with it and you commit to it from here on out, it's going to be good. So I need to know 0.06 times 0.97.
0.06.
0.06 times 0.97 is still 0.06.
Yeah.
Yeah.
It's because it's almost 1.
It's almost 1.
So just round
Okay, and then 0.06 times 0.03.
probably 0.0.
0018. So 0.02.
Makes sense. 0.018.
Tell me something, Hunter. Someone with a calculator.
Like 0.0018. Something like that. It's something real small. So it's like 0.002.
Points for people who can multiply. I need these
0.002.
ranges.
0.002.
Point for you. I need the next one. I need 0.94 times 0.94.
That's close enough. 0.94 times, so that's about
0.88.
Oh, that one.
Point for you. Is no one else getting a point? This table wasn't the only one literally who
Okay.
can
So
multiply.
that one, and then that one. So is it 0.004 maybe?
0.94 times 0.06. They're literally the only group who can multiply because 2's not even doing math and I'm 3's just staring at me. Okay.
I lost a long time ago.
Do we get points for paying?
But this can't be right because I'm out of what?
We're testing.
I'm trying to take a test.
Holy God. Yeah, so that last one has to be 0.04 or something because we rounded too much.
So let's go back to this one. It was 1.8.
Yeah.
So let's change that to 0.18. So let's stop with Louise is right. Stop rounding to 2 decimal places. Maybe let's round to 3. So instead of 0.06 for the top one, is it still 0.06? Change it, Hunter.
I got a 100 on it.
How did you get a 100 on it?
It's not.
I have my table set up differently than you.
Just tell
still
us
has
the
numbers
numbers.
though.
6% for true positive, 0.3% for false positive, 91% for true negative, 2.7% for false negative.
Yeah, but they at least tried to roll with me. You didn't even try to roll.
What?
You just decided to not.
I stuck with the first one because it made
Not
more
you.
sense.
I'm not
You
talking
seem
about you.
personally offended.
I love
Wait,
Friggin' Sally Lyle.
You know what I'm personally
It's
offended
this
about?
bullshit.
I connect
Well, I
that.
understand
I feel that.
because y'all keep saying that.
You understand that a lot.
Okay.
And some of their stuff bullshit.
I'd much rather talk about that.
Whatever. It adds up close enough to 1. I'll give you that. So you did the 6, the tell me again, Hunter, one last time.
It's 6%, 0.3%, 91%, and 2.7%.
So we're changing our things. Our last numbers are 6%, 0.3%, 91%, and what was the final one?
2.7%.
What's the 0.3%?
Okay.
False positive.
Yeah, but it's
I don't know.
0.06.
I don't know. I'm not gonna go find you any Shalia, no offense.
They still have the same numbers.
I'm sure I do somewhere in my life, but I'm not stopping. Okay, so those of you who tune me out, tune me back in now. Okay,
No.
So- we've made up some numbers, just FYI. We've completely, why am I talking to myself? 3, you can have a point. Think, you can, no. You can't have a point. Dude's gonna be watching a video on his phone.
You gave
You cannot have a point.
whatever.
I'm sorry that Cody makes bad decisions sometimes.
Okay, so it doesn't matter if our numbers are completely right or completely wrong. All that matters is they add up to 100%. So we decided to go with 6%, 0.03, 91%, and 2.7%. So the probability that they tested positive would mean, so we need to see the test results were true
Well, just the test
or the
positive.
lie. Say what now?
Which is the test positive, right? So it's 0.06.
Yeah.
And then has cancer. So all of the, well then it's 1%. Right?
So in the numerator, we still have to put they have cancer and they tested positive. So it's going to be what?
So cancer tested as a true, whatever that double message at the top left. So cancer tested true.
So what number do I put?
I don't know, I can't read it.
If you in writing things are in your own paper.
Nope.
Would it be the percent of true positive over positives in general, over the percent of the final percent that I put for true
Yeah,
positive
so-
over the one that goes to true positive?
That's the issue that Louise has. That's the issue with Louise. So
For what? Why would it not be 0.06?
For a day that we've gotten little to nothing done, I feel so satisfied about this day of work.
I got 0.94
no, I'm just
over
really
0.06.
mad about it, to be honest. Okay, so Louise is reading through the cancer and test positive,
Yeah.
which is 6%. That would be the overlap of they have cancer and they tested positive. So the
Wait, wait,
0.06 would be in the numerator.
Well, no, but wait, the test says they have cancer, that's 0.06. The top, it says 0.04, the test says they have no cancer, but the test positive is 0.06, right? Because it says test positive, or test they have cancer, 0.06, test they have no cancer, it's 0.94. So they tested positive for cancer, it's just 0.06.
But they have it. They don't. They're not in the not haves. They're not in the no cancers.
Yeah, so,
They're in the cancers.
yeah, exactly, 0.06, that first one, the very first one, yeah. It all it says is that they test positive, whether or not it's a false positive or true positive doesn't matter, it's whether they test positive or not, right?
Right. So you. Oh, yes. Keep going.
I can't read the other ones though, so I don't know. It's too much.
But you want to add those two up.
Add both of them. Why? Why
There
wouldn't you
is
just
too much going on that one.
why wouldn't you just add up, or why wouldn't you just have the very top one? That they had cancer and tested positive.
Wait a
Okay.
minute. If the test goes to positive, I'm gonna just think Louise just connected some dots in my brain. When you add the 6% and the 0.3% and divide it and put the 0.94 on the top because that's the amount that was actually positive.
Why would you do the 0.03 though?
Because it says they tested for cancer, but they don't. The thingy says that they tested positive for cancer and they actually have it. So would you just have the top left, the very top branch of hers anyway, much easier to different, but right? Because
No, it wouldn't be the issue because it says the question says that the machine is correct in the scanning.
or even besides that, is it the probability that women selected at random have breast cancer? Isn't that just 1%, like it said in the STEM? So 1% over 0.06.
I think so.
Right? That makes sense.
Because that's the total of women that have cancer over the probability that it will be positive and it's reading correctly.
So,
So 17 point something.
well, the stem in the first one that says they have it, it doesn't say they didn't have the false negative.
But oh wait, that's right. It has to. Yeah, you're right.
So we're not considering those.
So then yeah, so it has to be the very top one, right? Because it says. That
You realize so you realize tomorrow I'm gonna make a video finishing up the rest of these notes, just FYI.
Yeah, no, I was just
Okay.
gonna
So-
do my best to do what I can for practice.
So they tested positive and it's true, so it has to be the very top one.
Yeah.
So it's not 0.1 or whatever. It's the very very top one. I can't read those like 0.0.
058.
Okay. So yeah, that's very close to 0.6. What 0.06?
But I guess that would make sense because we would pray that you actually have cancer and you tested positive would be about the same amount as you actually have cancer. So yes, the test failed that 0.002% of the time, but we would pray those numbers would be close anyway, or else why are we testing for cancer because we're failing every time? So we would want those two numbers to be close. So I'm believing this because those two numbers should be close. You would pray that if someone tested for cancer, that it would be positive if they actually had cancer. So that should be a really good percentage. And so I don't have the patience or the time to type that in and get the actual percentage.
Jackson has a question.
Yes, dear.
This is 96.
Say it again.
96.
Thank you. Jackson.
Oh yeah. So tomorrow we have any time in here at all?
No,
Not even like
No,
never
I don't think so. Which is why I'm going to continue talking now. Sorry, I love you though. Okay, find the probability that a woman, I don't think so at all. That a woman selected at random does not have breast cancer. so no cancer, given she had a negative test.
Negative test. That's 0.94.
So the test was negative 94% of the time. And then you have no cancer and the test was negative, that was 0.8836. 8836. But again, yes, I realize those numbers are close, but we would pray those numbers are close, or else, why are we having these tests if they're not somewhat the least bit accurate? So we get 94%. Part D. What is the probability that the test is reliable?
So would you multiply the truths? Would you multiply the truths?
Or you could do 1 minus the falses.
But it would make more sense.
Yeah, it would make more sense to.
Right.
Okay, so the 2 truths are what?
I don't know.
Wait, is it 94% or 0.94%?
94%, 0.94 is 0.94 is 94%.
Okay.
Wait, 0.06 is 6%.
You just look connected because I just had to look back up for a second.
Okay, but part D, I'm still not. What is the probability that the test is reliable? So they tested for cancer and they had true results, which is what we already figured out, which was the 0.96.
When you take the amount of true results over the total results,
You could do that, but I mean, we could, they're building upon each other. B was they have cancer and their test was positive, which means that the test was reliable for them. C was no cancer and the test was negative. The test was reliable for them. So why not literally multiply the 0.96 times the 0.94? Because this is people who actually have cancer and they did test positive. And these are the people who had no cancer and tested negative. So, I mean, it makes sense to multiply those two numbers.
90%.
So it's 90% correct. Okay, so we BS'd our way through this, and some of you lost patience, which is just sad, because I don't know what you're going to do when the actual free response happens, and I'm not there to, hold your teeth to it or whatever.
cry.
I don't know what you're going to do.
So 1 out of 2.
But the fact that we didn't get A right, yeah. The fact that we didn't get A right, whatever. So we get the P. On B, C, and D, our answers make sense because on B and C, they're really close to 100%. D is saying the test is 90% accurate. So we're going to get E's on all the other parts. So we're getting at least a 3 out of 4. And they might have mercy on our soul depending on how well other people did on part A. They might even give us the 4 out of 4. It really just depends on if there are other geniuses out there who actually persevered and figured out the true percentages.
Yeah, but that's also assuming those percentages are right, not them at all wrong.
No. If you roll with it wrong in A, they're going to roll with what you did wrong in B, C, and D.
Okay. So what would you do in that jumble test? How do they know what you're actually calculating?
I would unjumble my math. I would draw
All the
pretty
things
less.
that don't matter.
But again, I spent we spent some time working it out with each other. You would have gone a lot faster. I swear 13 minutes is plenty of time.
Basically, rate what you've learned, but it's not